For our next talk, joining us from Columbia University, please welcome fourth-year PhD student here to talk about his work titled JoinBoost, Tree Training with Just SQL. Please welcome Zachary Huang. Zachary, thanks for joining us.
Hey, Art, thank you very much for having me. Super excited to talk about my most recent projects.
Of course. Do you mind doing a 30-second self-intro and then please feel free to take over.
So, hi everyone, I'm Zachary. I'm a fourth-year PhD student at Columbia University. My research area focuses on building semantic layers to help you manage this large join graph in enterprise databases. And I'm super excited to talk about our recent project on how do you train machine learning models on top of enterprise databases. So let me talk about JoinBoost trains tree models on databases with only SQL. This is a joint work between Columbia University and Microsoft. So we all know that machine learning on databases is popular these days. Major database providers like Azure, Google Cloud, and AWS have been offering machine learning support for a long time, and it's proven to be super effective. On the other hand, tree models are dominant for tabular data sets common in databases. So as shown by the Kaggle survey last year, among all popular machine learning algorithms, decision trees, random forest, and gradient boosting take the lead. In response, machine learning communities has developed libraries like LightGBM and XGBoost that offers user-friendly API and superior single-node performance. So now you may think that applying tree models to databases is natural and easy. Databases are full of tabular datasets, and the tree models are specifically designed for them. However, the process may not be that simple, as discussed next. So let me illustrate the challenge with an example. Imagine that you are an owner of a global bakery chain, and you have been collecting customer ratings from platforms like Yelp and Google. These ratings, like the one to the right, are precious data for your businesses, but now you want to use them to predict the future customer ratings. So ideally, to build a machine learning model for rating prediction, you want to go to your database, specify rating as your target variable Y, and pick features such as the cake price, customer age group, weather, and location as X. Then you feed this table into the machine libraries and hope that it magically returns an impressive model to predict future rating for business decisions. However, this process is not as easy as it sounds. So the core challenge lies in the impedance between how databases and machine learning libraries handle datasets. Databases store datasets across various tables. For your bakery chain, the ratings are in the middle table, but other features like customer age group and the stored locations are scattered across different tables. However, machine learning libraries require a single table with both feature X and target variable Y as inputs. So this creates a gap between how database and machine learning structure datasets. So the current solution to bridge this gap is to use a SQL query to join tables, materialize the results, and export it to machine learning libraries. However, such process causes lots of troubles. Firstly, this join, materialization, and export is laborious. So ideally, we will just select the feature we want for machine learning from the databases. But in reality, we need to navigate through a complex schema to write SQL. And the structure of enterprise database schema can be very complex. So take a look at the IMDb schema displayed below, which we refer to as the galaxy schema, because tables are scattered around like stars in the galaxy. And imagine having to navigate through this graph, writing these long SQL queries, and ensure its correctness. It's quite a tedious work. Secondly, the join is very slow. So ideally, the majority of your time should be invested into improving machine learning models. But in reality, the join, materialization, and export process, especially for large data sets, can take hours to complete. So our experiments show that the join process in databases take longer than the actual training. Lastly, it's a security risk. So as we transfer the raw data from databases to machine learning, we expose ourselves to potential data breaches. Imagine if the data contains sensitive customer information like social security numbers, the resulting legal issues could be a nightmare. So in short, previous machine learning libraries require moving data from databases, and use specialized machine learning system to train models, and this comes with a set of challenges. But what if we could reverse this process? What if we could train models using only SQL and thus bring machine learning back to data? So we introduced JoinBoost, trains tree models purely within data with SQL queries. JoinBoost is an open source project, and you can scan the QR code on top right to check out our GitHub repository or a live code demo. So instead of moving data to machine learning, JoinBoost translates machine learning as SQL query and moves SQL to databases. So as a result, the training process is simplified down to executing SQL queries, and it all happens within the databases. Once the training is complete, the model parameters are returned as SQL query results. Note that your data never leaves the databases for strong data governance. So what exactly is JoinBoost? It's a lightweight Python library that is as simple to import as XGBoost and LightGBM with similar training APIs. But instead of running training locally or on specialized machines, JoinBoost plugs directly into your databases. Below is a code snippet of how you use JoinBoost, and I will walk through it next. So first, you need to connect to your database. JoinBoost is highly portable. It can connect to any SQL running databases. This includes single node databases like DB and Postgres, and even cloud databases such as Azure, Redshift, or BigQuery. Beyond that, it can connect to data frames like Pandas, R, cuDF, and Dask. Next, we map out the join graph. So unlike XGBoost and LightGBM, which only work with single table, JoinBoost is designed to manage multiple tables as a join graph. So in our example, we lay out a join graph with two nodes, sales and the date, each representing a table. We specify rating as target variable y and weather is the feature x. We link these two tables with the edge for the join key. So here they are joined based on the date ID. And in most of the cases, JoinBoost can infer the join graph automatically based on the primary key and foreign key constraints in your databases, and only requires user input for ambiguities. Finally, we move on to the model training phase. So JoinBoost trains machine learning algorithms using purely SQL queries and execute these SQL queries within the databases. For performance, it employs various optimization. The crux of this is a technique called factorized learning, which trains models over the join, but without actually materializing the join. This avoids the high overheads and greatly accelerates performance. And you can find more details in our technical report. So how fast is JoinBoost? When data fits in memory, JoinBoost is 3 times faster than specialized machine learning systems. We ran an experiment training random forest of 100 trees. On the graph, the x-axis shows the number of trees and the y-axis shows the training time. Starting from scikit-learn, which is a very popular choice, but it's also very slow. So we have to stop training only after 30 trees. Next up, XGBoost and LightGBM, they are much faster, but they start with a high intercept on the y-axis. This high intercept is due to the costly process of join and materialization, which we illustrate with the black dotted line. Finally, we get to JoinBoost. It's 3 times faster than the specialized machine learning systems, even when it runs on DuckDB, a general purpose database. This is because JoinBoost avoids the join materialization overheads, and it even finishes its training before the join materialization finishes. So what if data doesn't fit in memory? Specialized machine learning libraries like LightGBM and XGBoost can use Dask for distributed learning, and we compare them with JoinBoost using Dask SQL. And the task is to train gradient boosting on 4 virtual machines, each with over 100 GB RAM. We plot the training time against varying databases sizes to the right. So when the database size is 40 GB, JoinBoost is 9 times faster than XGBoost. And in contrast, LightGBM hit out-of-memory errors even on 4 virtual machines, and is therefore not plotted for database size equal 40 GB. And we can push the envelope further. So we increase the database size from 40 GB to 1 TB. For LightGBM, this task will be daunting, as it would theoretically require you to setting up and managing over 100 virtual machines. But for JoinBoost, because it translates training into SQL queries, it naturally piggybacks on cloud databases scalability. So the graph to the right demonstrates how the training time of JoinBoost naturally decreases with an increasing number of nodes in the cloud databases. That's it. Thank you for listening. And remember, you can always try out JoinBoost yourself. Simply scan the QR code at the bottom to try our demo on Google Cloud, which even works on mobile. Thank you so much.